I'm a chief architect for Canada and the central United States at Red Hat. Today we're going to be talking about security enhanced Linux for mere mortals. As you can see from the alphabet soup after my name, I've actually been around for a little while and I got a few technical certifications. So hopefully if you have any questions, I'll have answers for you. If I don't have an answer, I'll make one up. If that doesn't work, I'll go ask the right people. So feel free to ask questions. Do be aware that we're going to be moving fairly quickly today. What we'll be talking about is what is SELinux, where did it come from? We'll talk about discretionary versus mandatory access control. Talk a little bit about how SELinux works, especially the issues of labeling and type enforcement, and talk to you about how to deal with labels, both reading and setting labels, and then some real-world examples of things that I have seen, things that I have done where SELinux kind of bit me, and how to remediate any issues you run into. So just real quickly, my contact information, I'm fairly easy to get in touch with. I am thomas@redhat.com. Yes, I've been there for a while. You can also find me on Twitter, on Freenode, IRC, and my people page, people.redhat.com/tcameron. So, about Red Hat. Red Hat really leads the way in security enhanced Linux development. We've got a ton of folks, John Dennis, Ulrich Drepper, Steve Grubb, Eric Paris, Roland McGrath, James Morris, and Dan Walsh, all current or former Red Hatters, have been acknowledged by the NSA for their work on security enhanced Linux. And Red Hat has also been acknowledged as a corporate sponsor of the security enhanced Linux, or contributor, I should say, of the security enhanced Linux project. So we know what we're doing. We've been doing it for a while. SELinux actually came out of the United States National Security Agency. No such agency. I get to go and work out of the Tyson's office every once in a while, and in one of the many roles that I've had at Red Hat, I was a trainer for a while, and it was really kind of cool when you did a class when you're up in the DC area, right? Because you start the class off, and who are you, and where do you come from, and what do you want to get out of the class? And, you get someone that's like, I'm John Smith, and I work at a bank, and I'm really interested in security because we're a financial services institution. And you get someone that says, yeah, I work in a retail area, and we got PCI compliance, and so I'm really interested in security. And you get someone that's like, my name is Joe, and I work for the government. Next student, please. So it's always kind of cool to work in the DC area. Having said that, the NSA has been phenomenally good to the open source community. They've done a lot of work and given all of that code back to the community, which is really kind of contrary to what you would expect out of them, but the NSA has been phenomenal with open source. So originally a series of patches to the Linux kernel using Linux security modules. It was released under the GPL by the NSA in 2000, adopted into the upstream kernel in 2003. Now, this is how I felt about SELinux initially. Anyone roll out SELinux in the RHEL 4 time frame? God, I'm old. All right, so originally RHEL 4 SELinux was just painful. So if you feel the same way, you are definitely in the right place. So what is SELinux? SELinux is an example of a mandatory access control system for Linux. Historically, Linux and Unix systems had what we call discretionary access control. You had the concepts of ownership, right? You had the user, the group, and everyone else, and you had permissions on the file system. Users have the ability or discretion to change the permissions on their home directory. There's nothing at all that's going to stop somebody from going chmod 777 on their home directory, and there's nothing that's going to stop other people from getting into that home directory. Same way with services. In essence, the instruction manual was pretty much, there you go, here's the gun, there's your foot, knock yourself out. And historically, the root user was omnipotent. Whatever root wanted to happen on the system, it was going to happen no matter what. That's still somewhat the case, but on a mandatory access control system like SELinux, there is policy around access which is administratively set and fixed. Even if you change the discretionary access control, if you do that chmod 777, if there is a policy in place which prevents a user or a process from accessing that directory, that access will be stopped, and you should generally be safe. These policies can be very fine-grained, so they control the way that users and groups and sockets and Ethernet interfaces, directories, memory addresses, all kinds of things like that, how they interact with each other. In Red Hat Enterprise Linux version 6, you are generally going to run across two SELinux policies. There is the targeted policy, which says if there is a policy for a process, it is managed by Security Enhanced Linux. Everything else runs unconfined. It's a pretty good mix between having good control over your system versus having it so locked down that no one can do anything. And it sounds fairly limited, but there are hundreds of policies defined, everything from Firefox to Thunderbird to the DNS server, et cetera, et cetera, et cetera. Now, the other policy which you may run into is the MLS, or multi-level security policy. It's out of scope for today's session. This is typically only seen in those environments that have, scary three-letter acronym government organizations, DoD, CIA, NSA, blah, 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 blah. So it's fairly complex. We're not going to cover it today. Just know that that is one of the policies that's out there. Now, you can tell what your system is supposed to be running at by looking at the SELinux config file. It'll have a section in it that says whether it's in permissive mode or enforcing mode and what policy is supposed to be loaded. You can also run the command SEStatus or getenforce. This is just an example of the SELinux config file. Again, your policy is going to be right here, the type, and then whether or not we're enforcing is going to be listed right there. And again, I said you can run SEStatus. It'll tell you whether or not SELinux is enabled, whether it's enforcing, things like that. And then the real quick hit is getenforce, and it'll tell you whether it's enforcing or not. So there are a couple of concepts that you need to be familiar with to understand how SELinux works. SELinux is really about labeling and type enforcement. And let me tell you what that means. Files and processes and ports, et cetera, are all labeled with an SELinux context. For files and directories, that information is stored as extended attributes on the file system. For things like sockets and ports and things like that, the kernel actually manages those labels at boot time or when the service comes up. The labels are in the format user, role, type, and optionally level. For the purpose of this presentation, we're going to be dealing with the targeted policy, so user, role, and level don't really matter to the targeted policy. Just be aware they're there, but we're not going to be using them today. So what I want to do to kind of explain how labels work is look at a service which is fairly complex, has the ability to accept multiple connections on multiple ports from the network, and potentially has access to the entire file system. I'll use the Apache Web Server. Now, I want to make clear, the Apache Web Server is not inherently insecure. It's just that it's very far-ranging and has a lot of potential to, shoot yourself in the foot. So we'll talk about how the Apache Web Server is labeled. So the web server has a binary executable which runs from from user sbin. If you do an ls-Z on the file, you'll see that it's got the user, it's got the role, and the thing that we care about, the HTTPD executable type. That's the field that we're going to worry about for this class. Listen to me. You can't tell I was an old instructor, can you? For this session. If you look at, for instance, the configuration directory, sure enough, HTTPD config type. If I look at the log file directory, HTTPD_log type. If I look at the system content directory, sure enough, HTTPD system content type. And again, if I look at the shell script that starts and stops the service, HTTPD init_rc exec type. So we're seeing a pattern here, right? Labeling is really just a logical way of grouping things together. When I look at the process as it's running in memory, if I do a PS-Z, I see that the type is the HTTPD_T, or the HTTPD type. If you look at the ports upon which the web server is listening, even they have labels. So if I do and I'm sorry, it's kind of an eye chart, but I did a netstat-Z and I grepped out HTTPD, and you can see that they are running in the context or with the label of the HTTPD_T. And if I do semanage, which I'll talk more about in a little while, if I do semanage port-L to list all the ports that are managed by SELinux, sure enough, HTTP port type is associated with 80 and 443. We all know those, right? www and HTTPS. And then some other ports that are commonly associated with the web server. Now, if I look at another file, let's say the etc shadow file, we all know that's kind of a sensitive file, right? If I look at the etc shadow file, you'll notice that its type is shadow_T. So we've talked a little bit about labels. Now let's talk about how those labels are used in type enforcement. It probably makes sense for a process running with the HTTPD type context or label to access a file with the HTTPD_config type, right? I mean, that kind of makes sense. Do you think it makes sense for something running in the HTTPD_T type to access something with the shadow type, Raise your hand if you think it's a good idea for your web server, which is publicly facing, network aware, to access your Etsy shadow file, because we'll all shun you. All right? So, it probably doesn't. Type enforcement is just the part of the SELinux policy that says a process running with this type can access a file labeled with that type. Type enforcement and labeling are really the nuts and bolts of SELinux. How many folks came in here thinking, oh my God, SELinux is really, really hard? I promise it's not. It used to be. In the RHEL 4 time frame, it was kind of painful. But really, if you understand these two concepts, type enforcement and labeling, the rest of it is a cakewalk. So, how do I deal with these labels? Well, you've seen me run a couple of commands or screenshots of commands. The -Z argument will work with a whole lot of the GNU utilities that are included with Red Hat Enterprise Linux. You saw me do ls-Z to see the context or the label on the file system. You can use ID-Z to see what your SELinux user is. Again, in the targeted policy, it doesn't really matter so much, but you can do it. I can do PS-Z to see the context of processes that are running in memory. I can do netstat-Z. You saw me do that to take a look at the ports that were associated with the Apache Web Server. On the file system, I can actually create labels by doing things like CP-Z. I can copy and give a target context. Make dir-Z, et cetera, et cetera, et cetera. You can also use SELinux tools like chcon, change context, or restorecon, restore context, and we'll talk more about those in a little while. But contexts are generally set when the file is created. In general, the context of the file is inherited from the parent directory. Does that sound familiar? It's the same way when we create files, right? If I create a file, it's going to inherit ownership and permissions typically from the parent directory. SELinux context is the same with a couple of exceptions, which I'll talk about in a little while. RPMs can also set context. RPMs can define what context a file is going to be installed on the file system. Even the login process defines your default context as a user when you log in. Now, there is an exception. You remember I said that generally files are created with the context of the directory that they're created in? There's the concept of transitions in security-enhanced Linux. So it says if application of type X creates a file in a directory labeled type Y, that you can administratively define a context for the resultant file that gets created so it doesn't inherit. An example of this is the DH client process. You know, when you're using DHCP on your laptop, the DH client executable actually runs in the DH client type context. It creates a file under the Etsy directory called resolve.conf, right? Because that gets generated when your system boots up. And it would be labeled etct, except that we have a transition, or the policy author has a transition defined that says when that file gets created, it gets created with the network configuration type, or network config file type. So just be aware that that's what transitions are. You can also use you may have seen me use the semanage command when I did semanage port-l. semanage, the SELinux Management utility, can be used to read and set settings on your login information, your user information, the port that a process may bind to, the network interface, the SELinux modules, for instance, things like the network node settings, file contexts. This is important because the targeted policy does take file context, so we'll play around with this in a little while. You can set booleans, which I'll talk about in a little while, and even use semanage to turn SELinux to enforcing or permissive mode. So again, we'll talk about that in just a little while. So what does it mean if you get an SELinux error? It means something's wrong. Turning off SELinux is like turning the radio up in your car when it's making a loud noise. There is something going on that you need to address. You know, don't just crank the radio up and hope that it goes away. It means one of probably four things. It means that your labeling is incorrect, and that happens, and I'll show you some examples of that in a little while. No big deal, use the tools to fix the labels. And we'll talk more about that in a little while. It could mean that you've made a change and you need to tell SELinux about it. You need to tweak the policy. Not a big deal. Happens all the time. I'll show you how to do that in a little while using booleans, which I'll talk about, and potentially even creating policy modules, which is not nearly as scary as it sounds. There could be a bug in the policy. It happens, especially if you're out in Fedora land where things are churning and burning at a really high rate of speed, or when a .0 release comes out. I didn't say that. There are bugs in policy. If that happens, open a ticket with us. Don't file a Bugzilla report. There's no SLA around Bugzilla. Please open a ticket with us so we can address it. Or the fourth scenario is you are being or have been broken into. Man the battle stations. Take action. Do something about it. Was that a question or a stretch? Okay. If you got a question, just ask. So, you heard me talking about Booleans. What the heck are these Booleans that you're talking about? Booleans are just on-off switches. There are a ton of predefined on-off settings within SELinux. Things like, do we allow the FTP server to access users' home directory? In some environments, that makes perfect sense. In other environments, that's absolutely the last thing in the world that you want to have happen. So we have the ability to just flip a bit and say yes or no. To more esoteric stuff, like the Apache Web Server can use mod auth NTLM winbind for logins. Yes? Is that for user's home directory? No, that's just home directories in general, or any directory that is labeled as a user home T. So to see all of the Booleans, you can run get sebool-a, and there's a lot of them. I ran this when I was writing the slides. There's a couple hundred Booleans that can be set. And they're everything from, like I said, things like HTTPD. Like I've got one here that's, HTTP can connect to the network or can use home directories. There's a ton of stuff that you can turn on or off without having to do anything around policy. You just run a command. To set a Boolean, you run the command set sebool, set SELinux Boolean. If you want to make it permanent, pass the -P argument to it, whatever the Boolean is, and then 0 or 1. It's very straightforward. A couple of tips and tricks that I want to talk about. If you remember back in the early days of SELinux, where the ABC denial messages that came into varlog messages were just awful and cryptic and terrible, SE Troubleshoot and SE Troubleshoot Server will make your life about 1,000,000 times easier when you are trying to develop your SELinux policies. Install those two. They're going to help you diagnose and fix SELinux issues, and then either reboot or restart audit-d after you get done. So I just took a screenshot to show you that when you install these two packages, it drags in a ton of other tools and libraries and plugins. So SE Troubleshoot and SE Troubleshoot Server will be your friend when you're trying to muck around with SELinux, I promise. Then restart the audit-d service. And I want to take all this kind of theoretical stuff that we've talked about and show you some real-world examples. These are things that I've either done to myself, because I'm pretty good at shooting myself in the foot, or I've had customers that have come to me and say, hey, I'm running into these weird issues, can you help me out? So let's say I got a user, and we'll call him Fred, who wants to create his own web page under /home/fred/public_HTML. Maybe it's a departmental web server or something like that. So you're a good sysadmin. You've done this 1,000,000 times in the past. No problem. So you go and you edit the httpd.conf file, and you enable the userdir setting. So that's, we comment out userdir disabled, and we add in userdir public_HTML. So we're good there. You're free to continue to take pictures, but you can have this slide deck at the end of the presentation. You can have the whole thing. So you're free to take pictures. Don't get me wrong. It's just I hate to see you struggling with this thing when you can have the deck at the end. So anyway, we enable the home directory, and we restart the web server. We go ahead and we set the permissions on the /home directory so that the web server can have access to it, right? We do the chmod o+x on /home/fred, and we know the permissions in there are good, so we're in good shape there. Fred logs in. He creates his public_HTML directory and creates an index.html file. So there's old Fred. He sees that that's who he is. He makes his public HTML. He creates his oh-so-sophisticated web page. This is my home page. Creates his index.html file. Everything looks good. We fire up the web browser and now, I've done this 1,000,000 times. I'm a good sysadmin. I know what I'm doing. What the heck's the matter with this? And I love this because I'll have people going, I wasn't sure, so I set it 777 chmod plus rwx on like the entire directory structure. And I'm sitting here going, oh, God, no, don't do that. So as a good sysadmin, I know what I'm going to do. I'm going to go look in the varlog httpd directory because it's obviously a web-related issue. So I'm going to go look at the access.log or access_log and error_log. So I go and I look at the access.log, and it says, 403, which anyone who's played with web servers very long goes, permission denied. Well, yeah. Okay, no problem. I'm going to look at the error log. Permission denied. Okay, we already knew that. Not helping at all. So the next thing we want to do is, well, let's see if there's something weird going on the system itself. So we take a look at var log messages. And y'all remember, SELinux is really hard, right? SELinux, this is hard stuff, right? So I go look in var log message and it says, hey, dummy, SELinux is preventing the web server daemon from accessing home Fred. For a complete SELinux message, run this command. SEalert-L, and then granted, it's a big ugly UUID, but this is hard, right? So I run the command. And I find that there are two issues, and here's the beauty of it. It says in plain English, hey, HTTPD can't search home Fred. If you want to allow HTTPD to read user content, then you have to set this Boolean. And the way that you do that is you run this command right here, this command, copy and paste this command to fix the problem. Did I mention it's this command right here? Then down here at the bottom it says, oh, by the way, if you want the Apache Web Server to be able to access users' home directories, you need to run this command, this one right here. Now, it'll also tell you about creating a policy module. In this case, Booleans will solve the problem, so we don't need to create a policy module. But the cool thing is, even if up in the top part it can't find the issue or it can't tell you what to do, it's this command right here. It'll tell you exactly how to create a policy module. So, follow the instructions, set the two Booleans. I run the two commands, this command right here, this one. Run it twice, once against the HTTPD read user content, and the other one against enable home DIRs, and it worked. Okay, is that too hard for anyone? Because we'll shun you. We'll do it. So my point here is, people say, oh gosh, that SELinux thing, that's so hard. Bull. 5 years ago? More like 6 years ago? Yeah, I would have agreed. Today, this stuff ain't rocket science. Now, building the policies from scratch, we're a little more involved in that. But my point here is, when people talk about how hard SELinux is, and this is such a pain in the butt, and I hate, don't be thinking in terms of 2001. All right, so how can I look to see? Now you say, well, Thomas, you just set some Booleans. How do I know which Booleans have been set? Maybe I inherit a system from somebody. How can I figure out which one of those Booleans have been set? That's actually fairly straightforward. Take a look under etc SELinux targeted modules active, and there is a file called booleans.local. And it's fairly straightforward. It'll say, these are the Booleans which have been set on this system. And hey, look at that. HTTPD read user content is set to 1, and HTTPD enable home DIRs is set to 1. Fairly straightforward. Is that too hard for anyone? Stop. So now I do want to point something out. When you create a new policy module, or if you set a Boolean to be permanent, be aware of this. Everything under etc SELinux gets, under etc SELinux targeted actually gets deleted and rewritten when you run those commands. So if you go and you edit this file, and you don't pay attention to that line right there, do not edit directly. You will lose your changes, and it actually won't do anything, because this is just a human-readable marker file that the SELinux subsystem writes, so you know what's happened. This doesn't actually do anything. It's just for your information. So I actually did something to kind of show you guys what I'm talking about. I created a marker file. I just touched a file called marker, and I ran the set SEBool commands, and I said, then find everything under the etc SELinux directory that's newer than my marker file, and it's everything under targeted. So again, don't edit anything in there directly, because it will actually get regenerated whenever you run an SELinux command. So now let's ignore what I just did with the Booleans. Let's pretend that we got a fresh, brand new, clean system.
Question there.
Yes.
That means that at least there you can't tell what changed, just that something changed today. All those files now.
Yes, you are correct. I know. Kind of sucks, doesn't it? Yeah. But that's just the way that it is. because those policy files, because if you look in here, all of these .pp files, those are policy files. Everything that's a .pp is a binary policy file for SELinux, and then it regenerates things like the file context files and things like that, which I'll show you more about in a little while. It essentially regenerates the policy from scratch. So yeah, don't be going and willy-nilly making changes to SELinux. Although the beauty of it is, even if you do, go find any file that ends in local under the etc SELinux directory, and you'll know any changes that have been made from stock. All right, so let's say that we've got an unmodified environment. I haven't made the changes that I just showed you. A user, Wilma, you can tell when I grew up, right? I got Fred and Wilma. There's Barney in here too. She's a web content author, right? So she says, hey, sysadmin, I have set up the web content in my home directory. Would you please move it over into production? And you being the good sysadmin, do that. Now, I didn't say she's a very sophisticated web content developer. But she's created a directory called content. She's got her index.html file there. And you being the good sysadmin that you are, you log in and you move it over just like she asked for. Move /home/Wilma content to var /HTML. And when you go to test, now, again, oh, I know, I moved it over, so it's owned by Wilma. The web server can't access it, right? So I go and I look, and sure enough, I do an ls-l, and it's owned by Wilma. Aha, I'm going to fix this. I change the ownership of it to the web server, to root and root, because that's what content under there can go as. And in this case, what I'm trying to get across here is when you start getting these like weird things that look like permission errors, and you look at the permissions and the permissions look right, start thinking in terms of SELinux. It could be something that's mislabeled, right? So looking at varlog messages, again, tells you to run SEAlert, but here's the weird thing. I find the instructions that say, hey, run this command right here, run this command, and when I do, here's something that's a little bit weird though. I get the same kind of alert that I got earlier. It's saying, hey, read user content is not enabled, and home dirs, wait, what? We're not doing this in a home directory. We're doing this under var /HTML, right? ls-z will explain why this has happened. So when I do an ls-z, what is the label of that index.html file right there? User home type. If we have not specifically told Apache that it's allowed to access users' home directories, do you think it's a good idea to let Apache access users' home directories? Raise your hand. Oh, come on, I haven't shown anyone yet. So the whole problem here is it's mislabeled. So we moved it over so it kept its original context. To set the context, we can run one of a couple of commands. First, we need to figure out what that context should be, or what that label should be. I cheat. I just look at a known good directory. So I do an ls-z of var and I see, oh, there we go, system content type, HTTPD system content type. We can use that type as arguments to the chcon, or change context command. And the long form of this is, anyone else just a terrible typist? I'm a horrible typist. This will take me, I guarantee you, at least 5 or 6 backspaces to get done, right? chcon-u user underscore u dash r object underscore, oh, doggone it, tap, 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 tap. Okay, so this is the long form, and you can certainly do it. You specify the user, the role, and the type against whatever it is that you're going to be running the change context command against. Perfectly valid, works fine. Remember, though, that the targeted policy doesn't actually care about SELinux users or roles right now, so actually we can do the short form, which is change con type, HTTP sys content type, var /HTML index.html. That will work just fine. Nothing wrong with that. I, however, am lazy. First one to admit it. I don't like typing. I'm bad at it, and it takes me forever. So what I can do is I can use the chcon command with the -- reference argument. And this is awesome. Hey, chcon, go look at this directory and make that one like it. Lazy for the win. Now, if you're even, yes, sir. Exactly, very good. If you had just done, well, possibly. Actually, you probably would have been fine if you'd have just done CP instead of MV, because if you copied it, what would it have done? Where would it have gotten its context from? The parent directory. If the sysadmin had just copied instead of moved, this wouldn't have been an issue. I'm being kind of intentionally obtuse here just so I can show the stuff off to you. Otherwise, it just works too well. Seriously, when I first started doing this presentation, I first started doing this because SELinux scared me so badly. I was like, okay, I gotta go teach it, because if I don't teach it, I'm not gonna learn it. So when I first did it, man, it would be RHEL 5 time frame, like early days of RHEL 5. It was really easy to come up with examples of stuff, because this is broken and that's broken and this policy. Not that it's a bad thing, it's just things were being tweaked. When I redid this presentation for this year, I was calling Dan Walsh, who's the guy who's like our primary, the guy who writes all the SELinux policies, super, super smart guy, and I'm like, dude, would you quit making this stuff so flawless, because I can't find any examples. And in fact, the example that I use is a total hack. I'll tell you right now, it's a total hack, but it's a good example, I hope. Anyway, so, okay, I've said, we've established I'm lazy. There's an even lazier way to do this. It's awesome. Use the restorecon command. If I use restorecon, it restores everything that's in a directory to whatever the default context should be. So me being the lazy son of a gun that I am, man, I use restorecon all the time. Looks like there's a weird permissions issue here, and the discretionary access control looks good. Restorecon. I use restorecon-v to be verbose, -r to -R, I'm sorry, to recurse the directory. And sure enough, I run restorecon against var www.html, and it tells me, yep, I changed index.html, which was user home type, over to HTTP system content type. And then, success. Okay. Too hard for anyone? Restorecon or chcon. Seriously, that's like 90% of what you're going to run into. This stuff is not as hard as people make it out to be. So, where does restorecon get that information from? There's a file under etc SELinux targeted contexts files called file_contexts. There are other files in there like filecontexts.home and things like that. There are over 4,000 entries in that file. And it looks something like this. It's got entries for pretty much every component of the file system that you can imagine, and it sets default SELinux types for everything on the file system. For instance, there's var www.html, and I want you to pay attention to the syntax of that regular expression right there, because we're going to use it in a little while. So var www.html and everything under it is HTTP system content type. So that's where it gets this information from. And I want to show you something else. I'm sorry? No, it's actually shell. Yeah. Yeah, it's just shell. Because you do this from the command line all the time, and I'll show you in a second. So let's say somebody does something like, hey, I want you to create a web directory under foobar. Okay, you're paying the bills. So I create the directory, make dir-p/foo/bar. I define the virtual website in the httpd.conf file. It's there, it's good. There's my virtual host, and I'm pointing at /foo/bar, and I've given it the host name dummyhost.example.com. You create the index.html file. Again, I'm not a web developer, so this is dummyhost. There it is. We know it's good. We restart the web server. The web server comes up just fine. But again, we go to the test page, and here's something that's kind of weird. Wait, why didn't I get my index.html file? What's going on there, right? And so I go and I do the usual change, check the permissions, all that stuff's good. But now that I've been to this SELinux session, I think to myself, which log file should we check? Varlog messages, that's right. So I take a look in Varlog messages, and again, this incredibly complicated, difficult to use SELinux says, hey, run this command right here. So I run this command, and it comes back. Now, this time it actually is a little bit confusing, because I run the command, and it comes back and it says, hey, the web server can't access foobar index.html, and you need to run this command, semanage, file context, add the type, file type to your file. But here's where it gets kind of hairy. Where the file type is any of these. Okay. Now, do note at the end, when you look at the output of the SEAlert command, it will also say, once you have created the label, or once you've defined the label, remember that label gets stored in that file_context file, make sure that you then set the settings in the, on the file system. So use restorecon once you've done it. Now, here's the weird thing. We got this horrible syntax. It's not really horrible. It's actually just telling you the truth. It needs to be one of these or one of those labels. What directory should we look at to see what that should be? Where do we find the default file content or the default label for the web server? var www, right? So we can go and look again in var www, and sure enough, there's my HTTP system content type. Now, the reality is we don't just want index.html to be labeled correctly. We want foo bar and everything underneath it, right, to be labeled correctly. So use a regular expression, and again, in that file, you can totally copy and paste that regular expression. If you're not a regular expression wizard, no big deal, go look in the file. And you issue the command, okay, I did the ls-z, so I know what it is, and I'm going to say semanage, file context, add the type, HTTPD system content type, to foo and everything under it. Which actually kind of makes sense, right? We're going to put web content in there, so we want it to be labeled web content. And again, lazy, lazy, lazy. If you're lazy like me, you can use the -e or -- equals argument to semanage fcontext. Hey, semanage fcontext. Add whatever is going to equal this directory to that directory. And it does it, and it works. It's wonderful. Now, remember that when we use semanage fcontext, we are just defining what the file context is. We're not writing any extended attributes to the file system yet, right? We're just saying when we do relabel, it needs to look like this. So once we've done semanage fcontext, then we run restorecon against the directory, and it looks something like this, restorecon-v, because verbose, I like to know what's going on, R for recursive on foo, and it goes and it says, okay, I set foo, I set bar, and I set index.html to the correct SELinux context. Fairly straightforward, believe it or not. Once you wrap your head around type enforcement and labeling, this stuff's actually not nearly as hard as you would think. So then we go and we fire up our web browser, we test it up, and sure enough, this is dummyhost.example.com. So fairly straightforward. So let's say that we do come to the time where we do need to create a policy module. In the case that setting a Boolean or setting a label doesn't fix whatever the issue that you have is, you might want to create a policy module. Sounds hairy, sounds scary, it's really not. In this example, I installed Squirrel Mail because I kind of like to have on my little home web server, I like to have my email available through a website. So I went to go install Squirrel Mail on the web server, and I got it all installed and got it configured, and I went to go log in with Fred, and So I go, and just for grins, I looked in varlog audit.log, because that is where the actual AVC denials, the SELinux denials, that's where the denials actually get set. And anyone want to spend all day reading through that kind of syntax file? Raise your hand. Yeah, you're freaking me out, dude. You're kind of scaring me over here. No, I mean, this is kind of what we used to see from SELinux. But the more important file is, I look again at varlog messages, and it says, hey, SELinux is preventing the web server from making a connection on a TCP socket. Run this command to see more. And I run the command. And now, one thing that I do want to show you is, because now I have identified that this is an SELinux error, what I actually do at this point is I set the system to permissive instead of enforcing, and I run my application through all of its paces so that I gather all of the SELinux alerts at the same time, because if you don't do that, what happens is you have an alert, and you go, oh, okay, I can fix this, and you create a policy, and then that just exposes the next layer of being blocked, right? Because SELinux is probably going to stop you from doing a number of things if you're doing something non-standard. So what I recommend is, instead of fixing it and then running it and then finding another one, then fixing it and then running it and finding another one, don't do that. Just put it into permissive mode, run the application through all of its paces, which in this case is web service and then sending and receiving email, and then run or build your policy module. So in this case, I use set enforce to set the SELinux enforcement to 0. So it's going to be in permissive mode, still going to log errors, but it's not going to deny anything. And in this case, I log in, I send email, I log back in as another user, Barney, and I receive the email, so I know that my system is working correctly now. Now, I do run SEAlert against the latest error message, and it comes back and it says, hey, we are having, you can't, what is it saying? Yes. It didn't find any kind of a Boolean or anything like that. It says you need to run audit to allow. And the way that we do that is grep whatever you're running into issues with. In my case, it was the web server. So grep HTTPD from that file where the actual audit, or where the actual ABC denials is stored, varlog audit.log, and then pipe that to audit to allow -M, which means generate a new policy file. And I generally label it as something with the word local in it. Like I called it squirrel local. I meant to type squirrel mail local. I don't know why I didn't, but squirrel local. I have a local squirrel. And once it generates that policy file, I just use semodule to install it. semodule-I to install my squirrel local policy file. And now here's where the hackery comes in. I couldn't actually find anything that would really cause a true SELinux denial, so I kind of fudged this. I could have just set a couple of booleans and fixed this, but I wanted you to see the process, right? Grep your error out of audit.log, pipe it to audit2allow, and you will be able to generate a policy module. And it's real simple. For type HTTPD type, and type SMTP port type, and type pop port type, we need to grant to the class TCP socket the ability to connect to name connect, and the policy looks like allow HTTPD, SMTP port type, TCP socket, name connect. That is all there is to an SELinux policy. Now, this is kind of dry, and I wouldn't want to spend all day, every day doing this, but it actually, even if you look at it, it kind of makes sense, right? Well, the Apache Web Server needs to connect to the SendMail server, and it's being denied, so it makes sense that I want to allow one type, the web server type, to attach to the network, the TCP, or to connect to the SMTP port over a TCP socket. That's actually, if you know anything about network connectivity, that actually makes a lot of sense. So I run semodule-I against the policy file, the .pp file. Now I set enforce 1, so I've turned SELinux back to enforcing mode, and I log in, and it works. So I've just created my first SELinux policy module. Oh gosh, you're gonna make me dredge up like horrible, awful programming stuff. I don't remember. I think that I don't remember why it's name connect as opposed to connect. I don't remember. So one other thing that I wanted to show you is once we've tested it and once that application works well, what do I need to do if I want to enable SELinux? Let's say in my environment we've disabled or set to permissive our SELinux. What do I do if I want to spin it back up and start using it in production? Well, what you can do is go and edit the etc SELinux config file, which is just a symlink to which is symlinked as etc sysconfig SELinux. Set SELinux to permissive. Don't set it to enforcing, because you will have mislabeled stuff and your system probably won't boot if you set it to enforcing. So set it to permissive, create a file, and that's what that file looks like, sorry, so SELinux equals permissive. Create a file in the root of the file system called .autorelabel. You can just touch it, touch .autorelabel in the root file system, and reboot. When you reboot, your system will relabel the file system, and it'll look something like this. It'll take a while depending on how big and how full your hard drive is. You can kind of expect that it'll probably take similar amount of time to a file system check. Okay? So it'll relabel. You can also, if you don't want to reboot the system, although you're still going to wind up needing to do it eventually, is run the command fix files relabel. That will delete everything in your temp directory and it'll relabel your file system. Now, me personally, I recommend you reboot afterwards, but it's not a hard requirement. Don't do this in run level 5 because it will nuke everything in the temp directory and your X server will get really, really cranky without a fonts directory. That would be the voice of experience. So you run fix files relabel, it'll go through, it'll nuke everything in the temp directory. It doesn't say it, but again, I do recommend that you reboot. After everything is relabeled, then set it to enforcing and reboot, or just run the command set enforce 1, and that'll set it to enforcing mode, and you will have restored your system to SELinux capabilities. Now then, this stuff is so easy, even a Windows admin can do it. You're going to need to install, if you're going to SSH in, that's what I usually do is, I'll install the Xorg, X11, Xoff, RPM, and a font. I usually just install the bitmap fixed fonts. Or you can do yum group install fonts. And policy core utils GUI. If you do that, you can SSH-X into the box and run system config SELinux. This is what that looks like. You install all the packages. There they are. You SSH in and run system-config-SELinux. And you get a pretty intuitive graphical tool. It's actually fairly straightforward. You remember we talked about the default mode and the current mode? Guess what? You can do these from a graphical tool. You want to set the default policy type? You can do it in the graphical tool. You want to relabel on the next reboot? You press that button. You know what that does? Touch/auto.autorelabel. I mean, that's all it does. But here's the cool thing. It's a graphical tool. It's fairly easy to navigate. All the things that we talked about so far, I wanted you to understand from the command line first, but all the things we talked about, they're all there in the graphical tool. I can go look at the Booleans. I can figure out what's turned on and what's not, and I can actually use filters. So I can put in HTTPD and filter out all of the Apache ones. I can look at my file labels, including all those crazy regular expressions. In fact, I did a filter on foo, and look, there's that file system labeling that we set up. I can look at network ports, for instance. You remember we did se manage port -L to list all the ports? Well, I get the same content right here. I can even look at my policy modules. So, oh, I'm sorry, that's where I filtered it. So I filtered HTTP port, and sure enough, there's all the ports that we talked about earlier, 80 and 443, and then some other ones, 80, 443, and so on and so forth. I can also look at the policy modules that are running or have been installed by either by the operating system installation or by something that I've done. In fact, I did a filter on Squirrel, and sure enough, there's my squirrel mail, there's my local squirrel mail policy. So, that's all there is to it. You're not going to walk out of here after an hour being able to write policy from scratch. That's an unrealistic expectation. But if you need to manage an SELinux environment, this should at least get you started. And hopefully you don't feel like the 98-pound weakling before he saw Charles Atlas. Hopefully you're feeling a little buff and a little pumped, and now you're willing to go back and give this a shot. Yes, sir? Booleans will generally be applied after the policy. So, now, but don't do that. I mean, that would be kind of silly to set a policy and then set a Boolean against it. But so, final thoughts. Really, don't turn it off. It's absolutely worth using. This is government grade, like scary government grade security that's available for free. You don't have to pay a penny for it. It comes with the distribution. It will save your tuchus in the event of a breach. Raise your hand if you want to be the dude on the front page of the New York Times as the administrator who let that financial data get released. No? No takers? Yeah, me either. I have seen in the real world several cases where this actually stopped a bad guy from getting any further into the system, or farther. Anyway, any more into the system. It'll absolutely stop a bad guy because, remember, the whole point here is even if he does do a buffer overrun of the web server can't access anything that's not labeled correctly. Even if he does a buffer overrun on the DNS server can't get outside of just the area that it's been confined to by SELinux. So absolutely worth using, much easier to use even with the release of 6.3. I could not get an SELinux fault with 6.3. I had to kind of manufacture silliness just to show you guys this stuff. So it's available at no extra cost. Please use it. If you liked today's presentation, you have an evaluation form. I would appreciate it if you would fill that out. If you didn't like today's presentation, fill your eval form and give it to me. I'll take care of it, I promise. There are SELinux guides available at docs.redhat.com. You can also look at the Fedora project SELinux docs. There is the Fedora SELinux mailing list. That's the wild, wild west where a lot of the policy development and questions happen. Great, low volume. It's not a high volume mailing list. You can take an SELinux policy course from Red Hat. It's a 4-day course with a 1-day exam afterwards. I took it, I passed it, and I swear to you, if I can pass it, you can too. This stuff scared the crap out of me when I first started dealing with it. It's not nearly as hard as you would think it is. And then finally, access.redhat.com has got some phenomenal videos on SELinux. Dan Walsh, the guy who writes the policy for Red Hat Enterprise Linux, has done some really cool videos. Dave Eggs, who has probably forgotten more about SELinux than I'm ever going to know, and I know a fair amount about it. He works on the government side of the house. He's done some videos on doing like some really cool confining users and things like that. And then you can also go and read Dan Walsh's blog at danwalsh.livejournal.com. So any questions, anything we didn't cover? Yes, sir?
What about overhead? Because we're turning on auditing.
Sure.
Have we ever spec?
As a matter of fact, we have, yes. Generally, you are going to see significantly under 5% performance hit during the first read of a file, because where do we get SELinux attributes? They're extended attributes on the file system. Once that information's cached, it's negligible. And even on the first read of a file, it's negligible. When you do writes, there is going to be the additional overhead of writing extended attributes, but man, that's so tiny. It's there for sure. I'm not going to say it's no impact, but you know, in tests we've seen as high as 5% under really crazy loads to as low as imperceptible.
What about processes and ports and all the other?
That information only gets read when that processor port is instantiated. So it's a one-time type of deal. As the kernel is dealing with, checking labels and doing things like that, all that stuff's in memory when it gets done. So yes, there is an overhead, but again, our worst case under very, very crazy loads was less than 5%. Yes, sir. Mm-hmm. You can do that. You can write it. You can do a policy module or use SE manage port and make assignments in there. The reality is, if you're installing a third-party piece of software that's going to be doing stuff like that, that's going to be spawning a bunch of ports, by default in the targeted policy, since we don't have a policy targeted for it, it's going to run unconfined anyway, and you're going to be okay. Yeah. Yes, sir. Mm-hmm. Mm-hmm. Define nice. You can absolutely turn it on. You can use these tools to generate either policy modules or just set booleans to allow them to run. More and more, it's not universal yet at all, but more and more, I've got folks who are using all kinds of third-party software, including backup software and things like that in SELinux environments. You have to be really careful around backups because your backup software has to understand the concept of extended attributes. But yeah, it should work. It should work. And if it doesn't, again, because it's a third-party application, unless it's trying to bind to an SELinux-protected port, you should be fine because third-party apps that don't have SELinux policies for them run, by default, unconfined. Any other questions? Yes, sir. What about it? Very little, believe it or not, very little. The tools, the system config SELinux, that's there. Audit to allow is there. The SE troubleshoot and SE troubleshoot server are there. So it's really not a big stretch at all. There were, because SELinux is still being somewhat polished early on, like if you have some crazy requirement that you're running 5.1, for one thing, tell your application vendor to kiss your... But some of the early days of RHEL 5, there was some wonkiness, but no, for the most part, everything that I did up here is totally relevant to RHEL 5. RHEL 4, whole nother story. Well, guys, on behalf of Red Hat, thank you for coming to Summit. We appreciate you being here, and personally, thank you for giving me the opportunity to present to you.